All right, it's 9:20, so I'm going to go ahead and get started. Hopefully more people will jump on. But it is pretty easy today if you're good at finding factors and you're good at knowing your perfect squares. That's really all we're looking at today. And we are only dealing with multiplication today. Tomorrow we'll deal with the division. But let's look at our property. So here we are, our goal today is to simplify radicals or simplify square root expressions. So I want to simplify things like this, right? I want to be able to make that easier to solve, I guess. Make it look nicer, clean it up, make it like reduce it to lowest terms, so to speak, as square roots of things. And to do that, we're going to use our multiplication property of square roots. If you paid attention last week, I kind of told you this briefly what this does. But basically, if you have the square root of a times b, and both a and b have to be greater than or equal to 0 because you can't do negative square roots. So you have the square root of a times b is going to be equal to the same thing as them individually pulled apart. So the square root of a times the square root of b would be the same thing. And again, that's only going to work if a and b are both greater than or equal to 0. So to put that in the numbers, you get like the square root of 32. We know that 16 times 2 equals 32. Right, so 16 and 2 are both factors of 32. So this is the same thing as saying the square root of 16 times 2, because 16 times 2 is 32. And then we can pull that apart like we did with our multiplication property of square roots. This is saying the square root of 16 times the square root of 2. And in doing so, you actually can solve part of this, because you should know that the square root of 16 equals 4. And you don't know what the square root of 2 is. It's going to be some irrational number, so we're just going to tack it on in the end. So in other words, we're saying that the square root of 32 is the same thing as 4 square roots of 2, or 4 times the square root of 2. And you can get your calculator out and check that to make sure that's actually true. I'll get mine loaded here. It'll take a minute. Some more people start to jump on. There we go. And I can sit here and I can do the square root of 32 is going to be equal to 5.65, blah, that thing. Or I can sit there and do 4 times the square root of 2, and I get the same answer. So they are equal. We're just pulling them apart. So let's look at another example. So let's look at the square root of 192. Now there are many factors to the square root of 192. The issue you need to come up with is you need to find a factor that is a perfect square. So you should be thinking, I'm looking for 1. 1's a perfect square, but 1's not going to help you with this. So really 1 is not going to be useful. But you're looking for, let's see, 2 times 2 is 4. Is 4 a factor of that? 3 times 3 is 9. Is 9 a factor? Was it 4 times 4 is 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 169. And then if you know more of them, right, this here is a perfect square. These are all your perfect squares. So we're looking at 192, and we're trying to figure out, are any of these perfect squares factors of 192? And you can sit there, you can use your divisibility rules for some of them. I mean, 4 might work, I don't know. But you might have to actually bring out your calculator and sit there and divide some out. And get it that way as well. I believe there's a way to do it with factor trees. I'll look into factor trees. I want to say there's a way to do this with factor trees to find them. I'll look into that today and come up with it tomorrow if it's actually true. But I feel like there is. I don't know. I just kind of sit there and try them out until I find one. And you should be realizing that 192 is divisible by 64. And again, you can do that. 192 divided by 64 is 3. So I know that the square root of 192 is equal to the square root of 64 times 3. Extend that. And using your multiplication property, we know that this can also be separated to the square root of 64 times the square root of 3. We can solve for the square root of 64. That's why we needed a perfect square. If we didn't have a perfect square, then it is probably already reduced down as much as it can. But here we can take out a perfect square, so I can take out the square root of 64, which is actually equal to 8. And I can't do anything with the square root of 3. I don't have any perfect squares that are divisible by this besides 1, and 1's not going to change anything. So I'm just going to tack it on. So the square root of 192 is equal to 8 square roots of 3. This here is the preferred answer over this. And again, you can get your calculator out and check that. Take the square root of 192. It's going to equal that crazy number. And 8 square roots of 3 equals the same crazy number. So they are equal to each other. Just remember, these are going to be irrational numbers, and this is a way of writing them so we don't have to sit there and write out the whole irrational number, because it's not going to stop and it's not going to repeat, so there's no good way of writing it. Here's your good way. This is how we want to see them. We want to see them as factors of square roots of things. And I think I got another couple examples here. If you're following along in the slideshow is really not that well formatted because it's hard to get the square root in there. But let's look at the square root of 50, right? We want to find a perfect square that divides 50. And you should be thinking 25, because I know 25 is a perfect square and there are two 25s in there. So I know the square root of 50 is equal to 25 times 2, right? The square root of 25 times 2, because 25 times 2 is 50. And therefore I know that the square root of 25 times the square root of 2, and therefore a square root of 25 I can actually solve as 5 and square roots of 2. So this here is the better way of writing it. So we are just kind of simplifying it down. We are going to get into some with variables today, so let's just do a couple more examples of these to make sure we get a little comfortable with them. And here we have 18. So think of factors of 18 that are perfect squares. And hopefully 9 is coming to mind. So I know the square root of 9 times 2 is 18. This is the same as the square root of 18 because 9 times 2 is 18. So therefore the square root of 9 times the square root of 2, and therefore square root of 9 is 3, and square root of 2 I don't know. I'm just going to leave it as that. So like that is my answer. Last example looks a little different because we have a negative and we're looking at the square root of 300. We have a negative 5 here. When we do things like this, just focus on the radical part first. So here I'm just going to carry the negative 5 with me to each step and I'll deal with it at the end. But let's focus on the radical first. So you should be thinking of factors of 300. Hundreds are easy because 100 is a perfect square. So I'm just going to tack on the negative 5. And I'm going to say the square root of 300 is the same thing as 100 times 3, because 100 times 3 is 300. And therefore, I can break that up. Again, just tacking on the negative 5, just carrying it with me. Knowing that it's still multiplication here, because they are smushed together. Just be aware of that. Negative 5 square roots of 100 times square root of 3. I can do the square root of 100. So that's going to be negative 5 times the square root of 100, which is 10, times the square root of 3. Now once you get to this point, you can combine your like terms here. You can do your negative 5 times 10. So this is going to equal negative 50, because negative 5 times 10 is negative 50, and then tack on the square root of 3. So you can do things with numbers out front as well. And that works pretty good if you do it in steps, because sometimes you got to double check it, and I'm not sure if I can think of any of these that'll work in steps. Let's look at the square root of 200, which is actually your first problem in your in your book, because this one here we can do in steps. You could realize that, hey, 100 is going to be a factor, but what if you didn't find 100? What if you found a smaller perfect square? Then it's not going to work completely, but you can do it in steps, just like when you're reducing fractions. If you find a common denominator or a common factor in both of them, but it's not the smallest or the largest, it will still work. You just have to do it in a couple steps. So here I know that the square root of 200, to get 200, right, I could be doing 100 times 2. But I could also be looking at it as, hey, that's 25 times 8. Let's do it if we notice this first, because 25 and 100 are both perfect squares. So this is going to equal the square root of 25 times 8. Then you're going to bring it apart and get 25 times the square root of 8. And that's going to equal 5 square roots of 8, which is different than if we did it with the 100, because if you look at the 100, you'll get 100 times 2, and that'll be the square root of 100 times the square root of 2, which is going to equal 10 square roots of 2. And these are still the same number actually. It's just that this one here is the preferred answer. So you got to look at this one here, 5 square roots of 8, and take it down again, right? We can tack the 5 on. Square root of 8 is the same thing as the square root of 4 times 2, because 4 times 2 is that, and we know 4 is a perfect square. So here you're going to get 5 times the square root of 4 times the square root of 2, which is equal to 5 times, and then square root of 4 is 2, times the square root of 2, and that's going to give you your 10 square roots of 2. So you do get the same answer. It's just that this one here, you didn't take the largest perfect square out of it, so now you got to do it in a couple steps. And it might be easier for some people if you can't find the factor right away. If you find, hey, one factor, I know this one will work, let's do it, and then make the problem different and see if we can see it differently then. And there's no shame in doing that. I mean, we do that all the time when we reduce numbers. If we don't know if the high enough factor is going to be divisible by it. So hopefully that's pretty simple. I'm going to get into some variable ones now. So let's look at it with a variable. It's still the same process. It's just that the variable tends to screw some people up, even though it kind of makes sense on how it works pretty well. So hopefully I can explain this the best I can. You got the square root of 45 times, what did I put, a to the 5th? A to the 5th. So I'm going to break this up into its factors. Right, I need a factor of 45, that's a perfect square, and I need a factor of a to the 5th, that's a perfect square. So I am going to pull this apart and look at it like this. However, I need to pull each of these apart and do it with each of these. So I might as well just do it all together. You're more than welcome to, because once you get to the variable, it's actually pretty easy. But over here, we have 45, and we know the square root of 45 is going to be equal to square root of 9 times the square root of 5. You get it that way. And we have the square root of a to the 5th. We actually are going to pull that apart. We're going to put as long as we're going to look at that exponent. That exponent is odd. You see that? It is an odd exponent. We're going to break it so it's an even factor. But we want it to be the highest even factor, so we're actually just going to subtract 1 from that exponent and stick it with the one that we can square, because I can take the square root of a to the 4th is just a to the 2nd. And we'll look at that. We know a to the 4th is a times a times a times a. If I were to take the square root of all of that, right, that would be the square root of a times the square root of a times a. And the square root of a times a is the square root of a squared, so that equals a. Right, and this will also equal a squared. So it's just going to be a times a, which is a squared. So this does just take away half of the exponents. Is what it's going to do. If it's an even number, it's going to take away half of your exponents when you take the square root of it. So if I had the square root of a to the 6th, it's going to equal a to the 3rd. It takes away half the exponents. If I had the square root of a to the 20th, it's going to equal a to the 10th. Again, it just takes away half the exponents. If you had a to the 2nd, you'll note it still follows that pattern. It takes away half the exponents. So what we want to do is we want to have one factor have an even number of exponents, and the other factor have an odd number, which is just going to be 1, because we're left with 1. Or it won't be anything, because we can take all the even ones out. So we're going to go ahead and do that, but we can do this together. So instead of doing it all separately, we can just think of factors of this. So this is going to be equal to the square root of 9, because of this, right? 9 times 5, so I want the numbers 9 times 5, and I'm going to stick the a to the fourth with it because I can take the square root of a to the fourth. I'm going to multiply that by the things I can't take the square root of, which is the square root of 5 times a. And then I'm going to go ahead and solve for this one. I know this is pretty easy. The square root of 9 is going to be 3. Square root of a to the fourth is a to the second, because again I take half those exponents and I can't do anything with this part, so I'm just going to tack it on, and it's going to be 5a. So this here is your better answer than this. It's more solved. It's simplified. We can do a couple more with variables, but again, you're just looking to get the number part the same as before, variable part, put all. If it's even, you can keep it like the next one. Square root of 27 times n squared. Right? If it's even, we can throw it all to the perfect square factor, or we throw all but one of it to the perfect square factor if it's odd, so we can't take the perfect square of it. So the variables are actually pretty easy to deal with. Here we have 27. So the 27 is 9 and 3, right? And then the variable is squared, so we're going to stick that with the perfect square one. And there's not going to be any variable here. I stuck it all over here. So over here, I can then solve for each of them. Square root of 9n squared is going to be 3n. Square root of 9 is 3. Square root of n squared is n. And then that's going to be multiplied by 3. So this here would be your answer. 3n to the square root, or 3n times 3n square roots of 3 is how you say that. 3n times the square root of 3. Sometimes we can focus just on the variables. Oh wait, no, we have another one. We have negative a. Sometimes the variable's out front as well. Square roots of 60a to the 7th. So it is, yeah. So again, we're going to treat this out front just like we did with the plain number. We're just going to keep dragging it with us. So we're going to start with a negative a. 60. Do we have any perfect squares in 60? That might take me a minute to think about. Let's see. Pretty sure 4 is divisible by 60. 4 times 15. So let's start with that. So I know this is going to be, right, 60 equals 4 times 15. And I know 4 is a perfect square. There might be a higher one, but this is the one I'm finding right now. So we're going to go with the square root of 4. And then we're going to take, because this is an odd exponent, we're going to take all the a's but one of them. So we're going to take a to the 6th. And then we're going to multiply that by the square root of 15, which I don't know. And I have one of the a's there. So my a's still add up to the 7, so I still have 7 a's. And 15 times 4 still gives me 60. I just brought that negative a over. I'm just kind of ignoring it till the end. Then I can go ahead and solve this. The square root of 4, well, here I got the negative a. I'm going to multiply that by the square root of 4, which is 2. And I'm going to multiply it by the square root of a to the 6, which again is just going to take half your exponents. So a to the 6 becomes a to the 3rd. And then you can bring that negative a into that and make that negative 2a to the 4th. Just by adding the a over here. And again, you're multiplying by a negative here, so everything's going to become negative now. So you could think of this as a negative 1 if you wanted in front of there, but it's just a negative. And then you're also going to have times the square root of 15a. So we'll bring that down, 15a. That's going to equal this. Over here, then you're going to take a minute to see if you can reduce 15a at all. I don't think there's any perfect squares that go into 15. It is not divisible by 4. It is not divisible by 9. And the next perfect square would be 25, and that's too high. So this here would be your answer. Again, just carried the negative a through it all until I could combine it. Separated out the factors that I could figure out. Make sure one of those factors has to be a perfect square so I can solve it. And with the variable, just make it one of them have an even number and the other one have the leftover 1, and you'll be good. Or if it's already an even number, you can just get rid of it by taking half of it. The next example was just variables. So this was the square root of x squared and y to the 5th, I think. I don't know, my screen's really small. Yep, x squared and y to the 5th. So here you can break that up. Again, you can do perfect squares on one side times the not perfect squares, and here you're going to have x squared is a perfect square. And then we're going to take all of the y variable except for 1, so y to the 4th is a perfect square. And then over here you just have the square root of y. Over here you can simplify it. I'll do it below. So the square root of x squared is x, and the square root of y to the 4th is y to the 2nd. And then you just tack on your square root of y. So this here would be your answer. So again, not too difficult yet. Just trying to get better at this. I don't know what other examples I got. Did I go into the next thing? The next thing is just kind of doing it in reverse and then simplifying it. So we can go over that today. We have time, right? Multiplying, I spelled that wrong, 2 radicals. So these are questions like the square root of 8 times the square root of 12. In this case, you know, but based on that property that we said at the beginning, right? The square root of AB equals the square root of A times the square root of B, as long as A is positive and B is positive, right? So I know that 8 times 12 gives me the square root of 96. So hey, that was easy. But actually we can reduce the square root of 96, like we've been doing since the beginning of this lesson, right? So we can do, well, we could have done these individually first and then done it, but let's do it all together in 96. I know 96 is divisible by something. According to my notes, I found it was 16. I know 96 is divisible by 16, so 16 times 6 equals 96. So I know it's divisible by 16, and 16 is a perfect square, so I'm going to rewrite that as the square root of 16 times the square root of 6. I can solve the square root of 16, which is 4. I cannot solve the square root of 6, so I just tack it on, and this here is my simplified answer. So the square root of 8 times the square root of 12 equals 4 square roots of 6. And you could have done that individually with these as well if you wanted to. Actually, maybe that might be tough because of the square root of 12 there. But let's do it anyways. So the square root of 8 is equal to 4 times 2 times the square root of 12. Here we can do 2 because the square root of that, and then times the square root of 2 times 12 is 24. And I know 4 is also a square root of that, so now we have 2 square roots of 4 and times 6, which equals 2 times the square root of 4 times the square root of 6, which equals 2 times 2 times the square root of 6, which equals 4 square roots of 6. So you do get the same answer if you did it individually, but it's probably easier to just bring it big and go that way. With that, your homework, I'm not sure what we got, is 581. As you do 1 through 24. They go fairly quickly once you get the hang of it. But if you have any questions on those, if you're looking at them and there's ones on there that you look at and are completely lost, let me know. You got maybe 10 minutes here still to talk if you have any questions. So now it's up to questions. Also, if you had any questions about the test yesterday, I can go ahead and help you out with those if you didn't understand what I was asking on something. But I would like to get your test by the end of the week. I'd like to get all your homeworks by the end of the week, so that includes this one. I am currently updating science. My goal is to update science by the end of the day and get all your grades in for science that I have. I know some of you are still working on the forces chapter, which is fine. I did unlock the next chapter, and I do expect all of 8th grade science to be due by the 20th. Once you get that in, I'm not going to be assigning anything else for science. So that gives me time to get your grades together and figure out your 8th grade awards, which I don't really know what is yet because I've never been here for 8th grade graduation. But if you could work on your science, that would be awesome. I would really hate to be just bugging people constantly to get it in. You still have plenty of time to work on it though. Okay, well, if you have no further questions, I'm going to stop there. Let you work on the radicals, let you work on your test. Tomorrow, if you have questions, bring them. Or you can email me. Watch your grades. If I mark something as missing and you turned it in, please resubmit that because I probably lost it somewhere. Or it was submitted after I actually went through all the grading of everything and I didn't catch it looking over it for a second time because it was done late or something. So make sure you get that in. And with that, I'm going to stop. Have a good day. Talk with you later.